Couple of examples of string inverters, typical installation layouts. On the top left area of the picture, we see a room, a closed room, and it is air conditioned. Must be air conditioned because the string inverters get hot. We have here several string inverters. The heat is accumulated. We have to keep down the temperature in that room in order to increase the efficiency of the inverter themselves. There's a main electric console on the left part of the left picture, which collects all the AC lines coming out of all the inverters into one big main electric console and out to the grid. On the bottom left picture, we see a different configuration of a layout, installation layout of string inverters. A line of string inverters up in a balcony, and on the left part of them is again main electric console. Collects and combines all the AC electrical energy and into one particular console and send it out to the grid. The reason it is a balcony having a ladder is to isolate this area from the day-to-day ongoing activities on the bottom, and also to place them as close as possible to the roof itself. The panels in this particular example are on the roofs. We want to shorten the distance between the level of inverters and the level of panels, because that distance is only DC cables. We want to shorten the length of the DC cables in order to reduce the level of voltage drops. This is why sometimes we put a balcony, and in the balcony we put inverters. Wall mounting. One string inverter after another, and they have a bus underneath them. This bus underneath them, this is in the top right picture, collects all the AC output energy and send it in the bus, metal bus, to the main electric console. On the bottom right picture, I put an emphasis on the breaker. Each inverter has its own personal breaker. We've talked about it before for safety precautions. This is a manual breaker. Also, semi-automatic ones. If there's a power cut in the grid, that breaker automatically cuts off. In order to split, to cut, like we've mentioned before, the AC side from the DC side of the entire system.